Welcome, everybody, to this edition of X Live, hosted here from X Blue's headquarters in Saint-Germain-en-Laye. My name's David Cunningham, one of the commercial directors of the company, and I'm joined by Christophe Corbier from our facility in the south of France, who's a business development manager for our SEAPIX and our fisheries product lines. Welcome, Christophe.
Good morning, David.
So we're here today to talk about SEAPIX F, the fisheries model of the sonar system, and we're going to be looking through the technical aspects of the product with a presentation of maybe half an hour or so, a discussion about the aspects of this, including some new features that we're going to be presenting here today for maybe the first time to some people. We're going to ask you to pose any questions you may have on the webinar platform as we go forward. Our goal is to answer all those questions at the end of the discussion. So don't hesitate. We'll be here as long as we get questions. We'll be posting a recording of this on our website after the event. So in case people were not able to join us, you'll be able to access it there. And we'll probably supply some an FAQ, a note on all the questions and answers as well on our website. So anyway, moving on. That's enough on the housekeeping. Christophe, thanks for being with us. Let's start.
Thank you, David.
And maybe you can just give us a quick introduction. SEAPIX, what problem are we trying to solve with this sonar system?
So, thank you for that opportunity to explain that. What is the main concern for fishermen is to have realistic information about what is going on below the keel and to evaluate if there is a quantity enough or too much quantity or the right species to catch below the keel. So the question is to provide more realistic information to fishermen. That's challenging.
Okay, so it's about bringing efficiency to their operation, according to the title of our thing. And so exactly what are we trying to do in order to do that?
So how to do that? It's a major challenge is to provide capability to go to the single fish detection. That's the main goal. But first of all, before that, I would like to explain you in very short how it is right now on fishing bridge. Most of the time, fishermen are doing single beam echo sonder assessment with 7 degrees cone vertically. So the inconvenience of that is that it's not completed survey thick of the water column, the volume. And another concern is they used to have several kind of echo sonder frequencies, different kind of echo sonders, and in fact it provides different resolution, volumetric resolution, and some different kind of picture on screen. And for fishermen, the question is to understand what is what and how he can believe on indication on echo sonder indication. That's a major concern for fishermen.
Okay, so we're moving with this technology. We're moving from the limitations of 7 degree single beam sounder, with multi beams. So give us a little snapshot on what that looks like.
Yeah. So that we would like to do is to go back to the single detection, right? And to be able to do that, we need to have a 3D pixel in the water that we call the volumetric resolution. So narrow and so small to be able to extract one fish per one fish in order to have the right TS value. TS value is the target strength. It's an acoustic echo of the fish. So that's very challenging, and that's the main focus of SEAPIX since the beginning of SEAPIX project. So, in fact, if we compare the regular echo sonder like that, it's a 7 degrees cone, and you should have several fish in the same cone at the same time. So you should have confusion on the backscattering level about that species, and as well, beside of that, you should have other detection not on show in that cone. We can really call it that this principle, this technology, provide several fish in the same beam, right? So it's not accurate enough to make a classification. So today on SEAPIX, we provide one beam per fish. Having 64 beams by 64 beams, we are able to get there one fish per each beam. So the TS value, the backscatter value, is much more accurate. Most of the time, it's much more accurate than classic 7 degrees split beam sonder, single beam sonder. Then we have one beam per one fish. And I have a good news for you, and for us, and for our customer and fishermen. We permanently perform improved capability of SEAPIX, and we have prepared the next generation software now available for SEAPIX. And we want to make it more and more accurate to measure single fishes. And to do that, we imagine to provide not only one beam per one fish, but to provide 4 beams per one fish to detect the fish. And we come from 64 beam to 256 beam, a cross track and a long track. So that means, David, we have total of 512 beams in the system, in the machine, in real time.
Okay, so we're going from sort of earlier technologies, single beam technologies, where you may or may not get a single fish, but likely you'll miss many of them.
Yeah.
The existing SEAPIX technology with 64 beams now to this new latest development, allowing us to process 4 times as many beams in both.
4 times. 4 times.
In both axes,
right.
which essentially gives you a much higher probability of detecting fish,
Yeah.
and then coming to the classification.
Yes,
aspect.
redundant, robust, whatever the condition,
Yeah.
with a 0.5 degrees spacing beams. So we really slice the fish, the biomass in the water.
Yeah.
So that's very, very accurate and redundant to provide realistic information.
So the goal then is to find individual fish with this sonar.
Yeah.
And maybe you can just now give us a little bit of an insight into how it can be installed and how it can be integrated on.
Yeah. So
on a fishing vessel.
in fact, the system consists on one transducer. This transducer includes all the electronic parts and even the motion sensor inside to compensate roll and pitch and eve behavior of the platform. And the coverage, angle coverage is 120 by 120 across and a long track. We are now providing 7 centimeter resolution in the water column with 8,000 sampling points in that water column at full range. So it's a huge resolution. So it's 6 times more than today. So that's a big improvement in performance. And as well, we use the high frequency 150 kilohertz frequency, but with extremely high power level. We provide 4 kilowatt power in the water, and it is a good compromise on quite good range. We can eat fish blue whiting at more than 500 meter depth, together with the high resolution from 3 meter from surface, 3 meter from transducer to 500 meter depth. That's very wide, full range capability.
Okay, so extremely versatile, and it's a sort of one sensor does the job of maybe what was done by 3 previously in terms of addressing the full water column.
Yeah, and in terms of installation, it's no more complicated than a regular transducer.
Sure.
Sonder, no moving part, no trunk required to install in the on the hull, on the blister. So that's very simple to install. So SEAPIX is not only one transducer. SEAPIX now has a concept of multi-head configuration. So depending on the fishing method, you should have one transducer down, and you should need for personing, for instance, side looking to increase control near surface at a 300 meter range on side, and so. And for that, we developed that we call the modular concept. Mm-hmm. And SEAPIX from now is not only one transducer, can be 1, 2, 3 transducer system. And one point here it is that all data from transducer are gathered and presented in the same screen as a fusion. We do fusion of data, bathymetry data, and biomass to provide very simple presentation, gathering all data from all sources. So that's very multipurpose and versatile, depending on the
Okay, so you've mentioned a couple of kind of enhancements so far of the technology, improvements, the multiplication of beams, so from 64 to 256, the increased sampling rate through the water column up to 8,000 samples, and now this option to multiply the sensors in a single installation, and then visualize the data from multiple sensors in one environment, giving you a really strong situational awareness of the biomass.
Exactly, and everything is real time. And keep in mind that here we have 512 beams running real time. With the dual system, we have more than 1,000 beams real time, calibrated. So that's amazing, amazing quantity of information in the water column.
Okay, so that's a little idea of how it can be deployed. And maybe now you can just give us let's have a look at some data and see how it looks.
So first goal of SEAPIX is to provide widest volume coverage to get all biomass from surface to bottom. On that picture, you have the real picture from surface with a blue layer, which is a mackerel, and a herring in the yellow and green dots. It is mackerel, plus the bathymetry, and plus the gear net presentation. It's provide for fisherman augmented reality, capable to give him a taste and feeling on what is going on. How he has to drive the gear more right, more left, more giving more depth on the troll to catch the right species, the right shoal.
Okay. So here we're going to dig a bit more into the classification topic a little bit later, but here you're seeing a visualization of the fish classification with color coding and the augmented reality showing using the net monitoring system, which is integrated with the SEAPIX software environment.
Yeah, exactly. So then we provide here a full coverage, water column coverage. This image is a good summarize to explain how SEAPIX is capable to perform from near surface to bottom. We can observe near surface mackerel here. We can have a herring. We can see herring diving down to the feeding layer on plankton, another plankton layer, and then we come to the bottom. And over the bottom, on the first 7 meters, we can observe single dots of detection. It is a codfish. We are talking about codfish at more than 200 meter depth, just over the bed. And as I said previously, the volumetric resolution provide capability to have one dot per fish. You know, not a banana with an assessment of several fishes as a signal, but one fish is one signal and as one TS value. That's a key for us to provide then the classification.
Yeah. Okay. And so this is giving you some idea of the power of through the full water column. It's up to 220 meters. Obviously, you mentioned a depth of 500 or
up to 500 for blue whiting, for instance. And for the bottom fish, we are more around 380 up 400. That's a range we observe. Yeah.
So give us some idea of some other quick idea of some of the other views that are accessible.
Yeah. So first of all, we provide a look-like sonar view, a cross track, a long track with bottom profile. It is a herring shoal here on the after side. Here it is a side-looking presentation with the vertical cut of the shoal, horizontal view, sky view, classic omnidirectional view, sonar view with bottom profile. So for a vessel having a dual system, it could have this one plus this one at the same time. So that's a sonar view. And here also we provide a regular echogram presentation, but with unlimited number of echogram. And that presentation, in that mode, it should be 4 echograms, a cross track, a long track, with the zoom, with the 8K point resolution zoom in the echogram. Mapping of biomass. So it's very interesting to see correlation in between the biomass position and the ground, and to understand the fishing ground, together with the bathymetry mapping, the hardness mapping, soft in blue, red, hard, and some ripple of sand on the bottom. It's bathymetry made by 256 beams across track. Can be also possible to make bathymetry ahead with the across a long track. That's very powerful for fishermen to understand where to locate the gear close to the ground.
Yeah. Okay, so we've obviously got a huge number of different visualization options depending on the operation and so on, and what's required at the time.
Yeah.
So now let's think about how we're actually going to go and deploy. How are we going to go to work with this system? How will it be used in practice?
So we understand that we have accurate information, we have volumetric information. What to do with that? And the goal of that is to help skipper to develop a real strategy of fishing, to make it better, to make it faster, and to save time, save fuel, and everything. So for that, another announcement today, David, is we are very pleased to tell you that we are now configure the software according to the fishing method. So SEAPIX skipper customer can open the system, start the system as a bottom trawler, or as a pelagic, or as a percenter, or as a tuna seiner. And in addition to that, depending on the fishing stage, searching for fish, approaching fish, catching fish, and so, it can use several type of operation mode. Some examples, so there is several mode per fishing methods. And some examples are here. So we develop special configuration for near bottom, deep bottom trawling, with providing, in that example, 9 echograms, volumetric echograms, close to the ground on starboard, on port, head, after side, and so. For pelagic, side-looking tuna seiner, dual head or triple head pelagic configuration. So there is a many choice for
Okay. So the improvement we're talking about here in the system is we've enhanced the software, the interface, the MMI, the man-machine interface
is completely new.
Is enhanced and improved in order to make it a lot easier to, let's say, configure the sonar and configure the visualization for a given operation.
Right.
With these standard sort of default settings that can be easily
be configured, selected, and then skipper can add some additional echogram, additional sonar views on and store it. And
presumably can be endlessly configured according to the the desire of the operator, the skipper, if he has a particular.
There is full flexibility, and I would like to underline as well. We have no limited number of echogram. We have no limited number of sonar views. So it's full flexible.
Okay, but the ease of use, just the default settings are just touch of a button and you're there and
Yes, just touch button and press on the icon and then you have it. That's very easy. So that's very important to.
So the next piece of the puzzle. What's the next piece of the puzzle?
The next piece. So we see how to handle the system now. How to select fish. How to select fish is crucial information is classification. Classification is based on the ranking of the TS backscattering. TS backscatter is the swim bladder of the fish giving the echo. And except such a special case like possible confusion between a Off mackerel, herring, of course, it's always difficult. We have about only 1 dB difference. The all species can be really distinguished by the TS measurement. TS is accurate, calibrated, and as whatever the SEAPIX system we deliver, we obtain exactly the same response because all systems are calibrated in at factory, and it means we can provide. For instance, weighting, ranking, or sizing ranking for the same species, or we can provide classification per species and give the ratio to the to skipper. Important thing is it is a real-time information. So the bar graph here with the percentage moves in live. So skipper can really react and see what is going on and see the mixture coming or pureness of species in the bag and react and hold the bag if necessary.
Okay, so this is obviously a hugely powerful function.
Sure.
Which is enhanced with, let's say, increasing experience. but also with the multiplication of the resolution, gives us
more and more robust
sensitivity to these measurements.
Yeah.
And presumably the higher sampling rate again can give us more confidence in the species assessment.
Exactly. Yeah.
In really, really powerful element of the story, which leads us then to the, how it all fits together for the skipper. How will he actually put this to use?
How to use that information? Now we are able to get our fish in a whole volume. We are able to classify it, and skipper is a fisherman, and he has to catch fish. So, which fish where? Now we have the solution, and skipper can really develop his own fishing strategy. Mm-hmm. What is a fishing strategy? In fact, fishing strategy is first of all to locate fish, to identify it, to classify it, mm-hmm. qualify in terms of species, but also in terms of quantity, of abundance that we provide here, and then locate the right place to catch the right fish, come back, shoot the net, and come back to practice a short time tow stage with the better profitability, less fuel consumption, and better quality fish in the bag. So it's a very interesting for him to compromise his efficiency, economical efficiency, and the sustainability rule he has to apply.
Sure. Yeah.
He has to comply.
So the idea here being then, just coming back to your operational modes and the kind of ease of use, it's he's able to select, depending on the type of fishing operation, he can choose the visualization and sonar settings which are appropriate for each element or each stage of his fishing strategy. And clearly the stage 2, the classification is a really strong
decision maker.
Yeah. So have I got the right fish? Have I got, am I permitted to capture those fish?
Yeah.
And then monitoring the actual fishing activity through this element here.
Yeah,
so,
and real time, thanks to interfacing SEAPIX with the net monitoring system, we could provide augmented reality in 3D of the fish coming, and with a classify color coding fish in the 3D and 2D. Okay. And that's a good way to react and to be sure the fish come in the bag.
Yeah. So with the enhancements now with SEAPIX, with the high resolution, with the improvements in the kind of ease of use, yeah. It really means this type of approach is even more, let's say, accessible.
Very easy, very easy to manage, very easy to handle. Yeah.
Than it was previously.
And graphic.
But I know that there's many people already using SEAPIX, many fishermen are already using it, and I know you've got a couple of examples here of. Maybe you can show us a couple of examples of where it's actually been deployed, and just talk us through the, what the experience is in the field already.
Yeah, so I can have two. I propose you two examples. First example is the most complicated example is to get our fish close to the ground. On that example, we have the bottom trolling example where we skipper face a mixture of three species, cod in that's a yellow point, haddock in red, and whiting in blue. So that's a mixture, and in a real time, skipper setup is class for that, providing a real time 75% of the cod abundance, relative abundance, statistical abundance, and we really understand where we have pureness of species. For instance, we have about a pure yellow point here, while we have more red inside the yellow over there here. So it's a very strategic decision information for skipper to understand how to drive the gear and to avoid a mixture or to stop towing because of the mixture of species. And depending on the quota he has, he can decide to stop towing to preserve the ecosystem and to be compliant with the rules. And here you have the figure of the 5-day fishing trip accuracy or error. That is the error in between SEAPIX estimation and the official declaration on the e-logbook, the real catch. And we are about 10 10 to 15% error on the estimate. So it's more than enough for fishermen, more than enough accuracy for fishermen to be able to target the right fish.
Okay,
and to avoid a bycatch.
So this is real data from
That's
real
real data
5-day,
from a real boat. Yeah,
5-day fishing,
5-day fishing
mission, and
yeah,
and so the performance of the system in terms of classification is 10 to 15% correct. Off the truth.
Yeah, it's 90% right. It's
So
80 to 90% right.
Yeah.
So it's much better than no information.
Sure.
And it for sure. Our dream, our goal is to make it 100% right, but it's something difficult to reach, of course.
So I mean, obviously, this factor gives the fisherman, let's say, some comfort in terms of his quota obligations and the rules obligations. But what other benefits does the system bring to an operation like this?
We can really consider that a bottom trawler or a pelagic trawler can reduce fuel expenses by 20%, bycatch by 30%, time at sea by 20% for the same volume of catch. So it's one of the good way to comply with the rule. Meantime, to increase profitability, economical profitability for fishermen. That's in fact, skipper becomes active, not passive but active, and makes the vessel plus the gear as the best selective tool. In fact, to make the vessel and the gear as the selective.
Sure.
That's
Okay.
it.
So there's obviously savings in time, fuel,
quality of fish. Quality of fish mean better price, so better profitability, and also there is a social aspect, less job to do on the deck to sort out fish and to manage to process the catch. So everything goes in the right direction for fishermen, and the economical margin is very beneficial.
Yeah, dramatically improved, whilst also obviously having the benefit of giving a bit, more comfort in terms of the adherence to the quota and the obviously the
sure, and that is very interesting. That's a real-time information. So in live during the fishing, some large boat could have in one shoot, in one bag, more than 400 tons of fish. If they shoot on a wrong species, we are talking plus minus 400 tons on their quota. So the impact could be about rules, but all about financial, economical aspect can be huge. Sure. So to have this capability to react in live is crucial. Yeah. Now it's crucial.
Yeah, that's very interesting. So you've got another example.
I would like to show you another example. It is the back to surface. We are on surface. It's story of tuna vessel, tuna fishing, red tuna, bluefin tuna fish. Here the concern are, first of all, to target the big fish, not the small juvenile, the big fish. There is regulation for that. Also, there is more value to catch big fish. First point. And second challenge is to provide quite good information about quantity, to assess and to have an idea of the quantity of the individual in the shoal, because of the size of the net is limited, and there is the risk of mortality in the net. And to balance that, they need to limit the number of fish in the net, and as well they transfer in cage. So it's very important. And here we provide the abundance figure together with the ratio in between the big fish and the small fish, relatively small fish, as a weight ranking. So we should do by length, but weight ranking is very relevant for them. As you can see on that picture, it is only the 2D, 3D picture. Of course, we have an echogram, we have sonars, but that picture provides one single dot per tuna. You can clearly see where are located the red point, big tunas and small tunas. Also, you can understand that even the vessel did mini tour, that's a track in orange, track line of the vessel, we still have a very clear picture because the target strength and the response from tuna is slightly different compared to vessel wreck and turbulence and everything that we can remove from the picture without losing any sensitivity on tuna. And then also the last information we provide here, and skipper like to have, is to have the behavior of the tuna. We can see line means the tuna is following the vessel at the moment. So it is very strategic, tactical information for per seiner, tuna seiner, but also it's about the same for mackerel, for herring per seining, or anchovy per seining.
Okay, yeah, so fascinating. Really interesting brief introduction, Christophe. And I think we'll probably call it to a halt there. I think what we're going to do is move on to some questions shortly. But I think the summary would be that, with the recent advances that we're announcing today with SEAPIX, with the increased resolution, with the significant improvements in kind of ease of use and the efficient setting up of the system for different applications, we've moved it to another level in terms of capacity to deliver something really, really useful for the fishermen.
Yeah, that's right. And I would like to say that that's a world first multi-beam, even more dual multi-beam, volumetric multi-beam, capable to provide more than 500 beams real time with a split beam processing inside and calibrated, accessible for affordable for fishery market. And it is fully calibrated, so it can be used for collaborative project between fishermen and research institute as well. So it is a very accurate tool at a quite affordable price level for fishery market.
Sure. Yeah, okay, great. So I think we'll move on to some questions, but I think the point here is we're going to answer all your questions. But if you would like to take up a more intimate discussion after the event, don't hesitate to contact Christophe or any of our business partners or our offices around the world to dig a bit deeper, look a bit more data, and so on. We've got plenty of material to share with you. So on to some questions, Christophe.
Yes.
Are you sitting comfortably? We've got the first question here. To have 256 by 256 beams upgrade, do we need to send back the SEAPIX to Xblue?
I have a good news. No. The answer is no. So we can upgrade it on board by software package as a software upgrade only.
Okay.
And the existing SEAPIX become 256 beam after the upgrade.
Okay, so it's a firmware and a software upgrade
for transducer delivered after December 2016.
Okay, so
but it's a major part of the fleet we have today on.
Okay, so the very early ones, it's not accessible, but really,
it's still possible, but there is additional cost, especially hardware to change.
So the answer is yes, but let's talk in more detail after the event. Okay, so next question. For bottom fish, what's the minimum distance to the seafloor SEAPIX can identify the fish and classify it?
Good question. So I had no time to explain that on that presentation, but more we have a narrow beam, more we are capable to go close to the ground to extract single fish to the ground. In practice, that we observe is that from 20 centimeter, 15 centimeter, we are starting to extract single fish. Mm-hmm. Of course, flat fish on the bed is still for the moment not detectable by SEAPIX. Even we have some idea to do it, and we work on that topic as well. But 15 centimeter.
So around about 15 centimeters from the seabed, we start to be able to confidently classify fish. So there's another one in the same vein here. So technically, why can SEAPIX bring a more accurate estimate of biomass close to the bottom compared with established low-frequency sounders?
Yeah, that's about the same topic. But that's an interesting question because what happens for bottom trolling, and deep layer, the skipper like to use the low frequency, like 38 like 50 kilohertz transducer sounder. The problem of that is the resolution is really low due to the low frequency, and then the radial resolution becomes very bad, and then there is a confusion on the first meter up to 1.5 meter just over the bed, and it's about impossible to really have the assessment in terms of quantity and even more in terms of TS measurement. And in that situation, the low frequency sounder provide a red band of fish, which is just a lie and not reliable. As skipper observes that sometimes there is a red band on their classic sounder, low frequency sounder, but they shoot that, but in fact there is nothing in the bag. So it's just due to lack of resolution. And SEAPIX, thanks to the combination of very narrow beam and now 0.5 degrees spacing in between beam and the vertical resolution of 7 centimeter is much more capable to recover fish close to the ground.
Sure, no, that makes sense.
Realistically.
Yeah. So you've got much higher resolution in the beams, and clearly the 7 centimeter resolution coming from the sampling in the beam.
Yeah.
Is
amazing.
It's going to give you a huge advantage over a lower frequency system. We've got one here from about research application. So this is for shallow water research. Can we pole mount the SEAPIX over the side of a vessel of opportunity?
Yeah, for sure. We develop a whole range of SEAPIX solution, SEAPIX transducer. This one is the hardcore transducer for hull mounting, for haces, hull mounting on fishermen or on fishing vessel. But we also have the composite configuration, lightweight and let's say portable, and you can fix it on a pool on the side for temporary operation, daily operation for survey, for research application, and also we could provide also autonomous solution for platform, from autonomous platform, like buoy, like drone, like surface platform. Yeah.
Sure,
whatever.
No, we've spoken about the potential for fixed installations, for unmanned vessels. There's a huge range of opportunities, but certainly it's well suited for temporary.
And one word about research application. SEAPIX even is capable to go on a quite deep range, up to 400 meters, for instance, is very suitable for shallow water survey, thanks to the coverage he has, even on a downward classic configuration, and even better by using the side looking. So we can really assess the whole ecosystem from the bottom to the surface with a 20-meter depth. It's a revolution for understanding of the spawning area. In the fjord, close to the coastline, it's really opening a new field of research.
Yeah, sure, very, very interesting. So here's one about split beam measurement. So you mentioned that SEAPIX provides a TS split beam measurement. In which swaths and how accurate is that?
So first of all, we do positioning of the target of the single fish in each beam. First thing, the accuracy is 0.15 degrees, plus minus 0.15 degrees in each beam. Each beam is factory calibrated for all beams and in all direction. So whatever the position of the fish in the whole volume, even on the side, even below the keel, straight below the keel, we obtain exactly the same TS measurement. That we do at factory, and for research purpose, we also provide a software kit, a special software suite for in situ calibration with a tungsten sphere, and then the scientists can make calibration on board the research vessel.
Oh, okay. Yeah. So there's calibration methods.
Yes.
For really optimizing the
for research. Yes. But for fishermen, from factory, fishermen receive deliveries are calibrated transducer from factory. So that's why also we can compare one trawler to another trawler result, and then skipper can exchange database and adjustment, fish classification, and everything. That's valuable for fishing companies.
Sure. Okay. Interesting. And this next question leads on from there. Actually, how can we build up the classification database?
Yeah, good question.
So learning from experience.
Yeah, it's we have now plenty of fishing vessels running, operating on such species we know very well, like herring, mackerel, anchovy, tuna, whatever, and so we prefer to let skipper to make it by themselves, but of course during training course we can give them some information and some settings. That's very easy to do. The main principle is to go on a pure monospecific shoal, just to store and record the accurate TS response on the curve and store it as a class. At the early beginning, you can name in class 1, class 2, class 3, and afterwards, after a catch stage, they can observe on the deck what they had, and they can make a very clear relationship between the TS response given by SEAPIX and the catch they had on the deck. So that's very clear. And step by step, skipper can improve, can make class per species, or can make in the same species, can divide the response in several weighting or several sizing.
Okay, yeah, and
they very flexible.
They can get more and more resolution to their.
Yeah, SEAPIX is so we used to hear sizing ecosonder. SEAPIX is more than it. SEAPIX is capable to provide ranking in a calibrated TS value on fish. So you can conclude by presenting statistical indicator index about weighting, or index about sizing, whatever, or both. And
I think, well, clearly you're in touch with skippers all the time. I know.
We are.
You know, helping them to move forward in deploying these sorts of techniques. And it's a very much X Blue's philosophy to stay close to the customer and to work with them to enhance their experience with the product. So here's another one. So for side-looking use on purse seining, what about tilt angle adjustments for the skipper? How does that work?
Oh, yes.
So we talked about the modes and the default settings. Okay. How can you adjust it?
It's a very exciting fishery method to person and or tuna seining because it goes very fast and skipper has to take a decision in very short time to identify and see if the depth of the shoal is right and so. And the main concern of the tuna skipper or personing skipper is to, when they use their omnidirectional sonar, to be able to tilt down according to the distance to the shoal. With SEAPIX, there is no concern with that. With SEAPIX, is capable to gather in about real time, the whole volume up to 400 meter range by using a side-looking transducer. And then when the shoal is approaching to the vessel, the system does not require any change of tilt because he ensures automatically the volume extraction, both direction, vertically and horizontally, of the whole volume in about 2 seconds. So it's a real-time full volume assessment, and the skipper has just to observe screen. And especially now with the mode of operation, he just has to select the way to present the stuff, and he observes screen and can make decision.
Okay, so very efficient.
That's very efficient.
Yeah. So the answer is
forget tilt angle.
The answer is you don't need to
adjustment. Maybe the only remaining adjustment is the range. You adjust the range. You want 400 meter range, or you want 200 meter, 100 meter. That's it.
Okay.
So doesn't matter. Even he can stay on 400 meter range.
So we've got another question here about what are the requirements for NMEA positioning? So looking at integrating GPS or GNSS.
Yeah, for sure. We used to use the GPS gyro system, very popular on a fishing vessel. We need the position, latitude, longitude, and we need the heading, the true heading. and that's it. And then SEAPIX manage by itself the roll, pitch, and eve. But in addition, we can even increase the roll, pitch, if compensation, if on board the vessel there is a very advanced available MRU, then we can connect it as an external sensor. But there is no need. It's not mandatory. It's not compulsory. We have everything available in the transducer.
Okay.
Yeah.
Yeah.
It's
So
very basic.
So you integrate a position and a heading.
Position and heading,
which could come from a satellite heading sensor or a gyro compass,
for instance.
Yeah,
it's already available on vessels.
We've got one here. Could you say a few words about the possibility of trawl positioning with SEAPIX F? And we mentioned a little bit earlier. Is there a pairing with Marport or ITI Simrad? This is the net monitoring systems.
Yeah. So we are compatible with both systems, Marport and ITI. We have to underline that the Marport system provide the more complete information at the moment, and it's compatible with the SEAPIX system. We have a fleet of about maybe today 20 vessels having interconnection with the Marport system with very good success.
Okay. Yeah. So yeah, we're compatible.
It's also
with both
compatible
those.
with Simrad and also with Notus. Notus system is also compatible.
Okay.
Yeah.
Okay.
Yeah.
Good.
And maybe in terms of one more about the compatibility, we also provide bathymetry and hardness to OLEX software. OLEX bathymetry software, very popular on a fishing world.
Okay.
Yes.
Okay, that's
in live.
So I guess in line with Xblue's approach to most of what we do, we try and stay as open as possible. And to be agnostic in terms of integration with third parties to get the best outcome for the customer in the end. That's our goal. So we've got another one here about so when doing pelagic trawling most of the year, but also sailing during a limited time in the year, can we use both methods using just one transducer? Is that?
Yes and no. The thing is, the best of SEAPIX for positioning, of course, is to install it on side, right? That's the best way. But even on a downward looking, we already covered 120 degrees, it's much more than the 7 degrees. So we can detect fish close to the ground, close to the surface. The best solution, temporary solution for vessel having season of bottom trawling, not bottom, but demersal, pelagic, and season of positioning, is to install ideally a dual system, of course.
Yeah.
But in terms of budget, if there is some limitation, it can start by using making 2 installation location on the hull, 2 blisters, 1 blister downward, 1 blister side, and one of the advantage of SEAPIX is we can install it by diver. So by changing configuration, a diver can dismount the installation downward to fit it on the side. And then in the fishing method, the skipper on the software has just to press sending, and then it become from trawler to center. The configuration, it's just like this. So just have to move physically the transducer.
Okay, that's
very flexible.
That's smart. Yeah.
That's very flexible.
Yeah. Have we got any?
We have some
customers already adapting.
Yeah.
Okay.
And for instance, we can mention that the SCAPECH in France, Intermarché company, has the trawler with the downward bottom trawling, and sometimes they do pelagic, and they move the transducer by diver for the pelagic season. It's very easy to do. There is no problem to do it, and it's quite fast. Just a cost of diver, but it's about nothing.
Sure.
Compared to the advantage.
And then in terms of the setup and the reconfiguration of the system, it's
just press on the other configuration. That's it. That's very easy.
That's really interesting. Mm-hmm. We've got more questions. You say the modular configuration of 2 or 3 transducers provides fusion of data of the transducers. Mm-hmm. But is it complicated to drive that that system for the skipper?
Yeah, good question as well. I explained that we do fusion, so we gather all information from all transducer to make it fusion and process at the same time to present it to the operator. Same for controlling the system. Skipper can, for instance, imagine a personer having one SEAPIX on starboard side, one SEAPIX on port side, and want to change the angle, the echogram angle on both sides. So he has just to change it on the system once, and all antennas, all transducer will follow up the control and will provide the fusion of the echogram, a composite echogram made from a part from the transducer from starboard, and a part of the echogram will be made by the transducer on port. So it's like a one single system.
Okay,
no complication.
So obviously the hardware integration is what it is, but actually from the operator's point of view,
for operator it doesn't matter.
It's kind of seamless, or it's a lot simpler than it might be, I guess, with these new features of fishing modes and
Yes.
and so on
As well.
We've got another one here about installation. So for installation, let's say in the case of repair of the equipment, is it necessary to place to come into a dry dock? And I think you've touched on this a bit earlier. So
yeah, as I explained, for the capability to move the installation by diver. Mm-hmm. So for maintenance, for guarantee, for servicing, SEAPIX is capable to be dismounted by diver and to be sent back to factory for repair, for servicing, without any dry dock. It's designed for that, and there is no risk to do it, and it is a part of our policy in the guarantee rules. Mm-hmm. So it's a very flexible. Yes, and also I would like to say that in case of impact on with an object or obstacle on the acoustic array, it's repairable. So this part can be exchanged, can be repaired, and for the skipper, for the owner, it is not the full cost of transducer to be paid. So that's smart compared to classic transducer, where it's a molding element and requiring a complete replacement of the transducer. Here we have a protection inside to protect water leakage, so we can repair the acoustic array itself.
Yeah. That's the end of our questions. We've come to the end, Christophe. So thank you very much.
Thank you very much, David, for the discussion and question.
It was fascinating. I think what I'll do is I'll maybe just repeat the offer to get in touch if you want to learn more, if you want to see more data, if you want to dig into the specific area of interest, then don't hesitate to contact us.
Yeah, we have many examples depending on the fishery and the depth, and so feel free to ask us, and we provide video info and features. So
we hope that you've learned something today about the latest improvements in the SEAPIX system. Hope you found it interesting, and we've recorded this, we're putting it on our website. So if there are colleagues or associates of yours who you think could benefit from seeing this information, then they'll be able to watch it on YouTube later. Mm-hmm. We're going to be carrying on with more X-Live events in the coming months. We're going to take a short summer break, but we'll be back in September with more new topics. I think that's all we've got to do today. So thank you very much for joining us, and we hope to see you again one day. Thank you. Bye.
Thank you very much.